So talking about a circle and the different parts, we're going to first discuss the different parts to the circles, then get into the formulas. When it comes down to your actual test, you will be given a formula sheet to be able to utilize, but it's not going to have every single detailed formula. There are some things that are just universal formulas, others that are a little bit more detailed. Kinston, that's your second warning. Okay? All right, so first thing I want you guys to do is to go ahead and draw a circle. Now, I know it's not going to come out perfect. Just do the very best that you can, okay? And in the circle, you're going to draw a centered point. And then a line that's going to extend from one side to the other, going through that centered point. And then another line that is going to go from the center point to a portion of the circle. And these all have different representations of parts. Now, the first part that we're going to talk about is this shorter one, the one that's from one point on the circle to the center. I'm going to go ahead and highlight that in pink. And who can raise their hand and tell me what this is labeled? What do we call this? Alicia? Yes? The centered point? No, it's called the center. Yeah, the origin is going to be when you're doing a coordinate plane. So if you're graphing on a coordinate grid, the origin is the centered point of 0, 0. That's the centered point between all the quadrants. Okay? But on a circle, that centered point is center. Center of a circle. That's its actual definition or actual vocab term. Okay? Now, who can tell me what do we call this measurement here for a circle that starts on the center and extends to one side? Does anybody remember, Caleb? The radius. Very good. So this right here is called the radius. And the radius is just the distance from one point on the circle to the center. One point that's on the circle stretched to the center. And the radius can be anywhere. As long as it starts at the center and goes to any point on the circle, that's the radius. So I just happen to draw it right here. This right here, if you look at my pen, if I start at the center and go right here, this is also called the radius. Start my pen right here, from my pen up, that would also be the radius. It's always from the center to one part on the circle. That's called the radius. You can draw it anywhere. But if we extend from the center to the end, and then in its opposite direction, so it looks like a longer point, it's a straight line that passes through the center, what do we call that? Anybody know what measurement that is? Rashawn? Not the circumference. Diego? Bryant? Diameter. This is your diameter, and I'm going to go ahead and highlight this one in blue. So this one is our diameter. And the diameter, again, that is the distance from one point on the circle passes through the center and extends to the opposite point. So we start at a point on the circle, go to the center, and continue extending until we get to the opposite point. That would be the diameter. So now, visibly looking here, I just told you guys, hey, from this point to the center, that's the radius. And then from the center to this point, that is also the radius. So what do you think that means? That the radius in terms of the diameter, if I was given the diameter and I wanted to know, hey, what is the radius? How do you think I can convert a diameter measurement to a radius measurement? What do you think, Rashawn? Well, we're not talking about circumference right now. Talking about if I was given the diameter and I wanted to instead find out what the radius was, how could I take the diameter's measurement and convert it to a radius? So what do you think, Kinston? Well, I want to find the radius, so I'm given the diameter, so kind of diameter divided by 2. Good. So you would take that diameter and divide it by 2. That would give you the radius. And then in the reverse, just like Kinston said, hey, if we multiply by 2, that would be your diameter, would be the radius times 2, right? This is a radii. This is a radii. Combined together, you've got your 2 radii. That creates the diameter. So one radius plus another radius, there's your diameter. Now, Rashawn kept saying that word, the circumference, circumference, circumference. That is this measurement on the outside. That would be this measurement here. Okay? And essentially, that's kind of like the perimeter of a circle. Remember, perimeter is the distance around a shape. So you'd add all the sides of the shape together. Well, here we don't have sides. We can't add sides together here because it's a circular object. So it's called circumference. It's still the distance around that shape, but it's the perimeter of a circle. So circumference, I've highlighted it in green. So that way you guys know to pair that with your definition. So this is the distance around the circle. And then last but not least, the thing that you need to make sure you know is that the measurement of pi. We use an approximation because pi is one of those irrational numbers. It has no stopping point. It goes on forever and ever. It has absolutely no pattern, no repetition. We do not know what its final value is because it doesn't have a final value. Okay, computers, there are some computers that can compute it up to like millions of digits long, but we only use the finite version of 3.14. We also use the fractional version, which is 22/7. That's the ratioed version. But we're going to focus mainly on using 3.14, okay, for all intents and purposes. All right, but if you were to type in 22/7 and convert that to a decimal, you would get 3.14159. It keeps going on, okay? So, formulas, like I said before, you will be given a couple of formulas on your formula sheet. Not everything. So formulas for circles. And now, if it's got a little star, I'm going to put a star by the ones that will be on the formula sheet. So put a little footnote. If it's got a star, it's on the formula sheet. If it does not have a star, it's something you're going to have to remember because not every formula will be on the sheet. Okay, so the very first formula I'm going to give to you is that circumference formula. So for circumference, you're going to take C equals your diameter's measurement times pi. You know the diameter, and you multiply it by 3.14. That is the circumference of the circle. This formula is on your formula sheet. Yes. They will give you either radius or the diameter, or they might give you circumference and you work backwards, which we're going to talk about that in a moment too. Okay? Area. Now, I like to write that it's area, and I put a little 2 up in the corner to let you remember that the unit is always squared. So it's inches squared, feet squared. So when you're writing down your unit of measure, if it's circumference, it's just feet or inches or yards. But if it's area, it's feet squared, inches squared, yards squared. Okay? So area uses the radius. So you take the radius, raise it to the second power, r squared times pi. This is also going to be on your formula sheet. Now, the items that I'm going to state that are going to be in reverse, which is what I just told Rashawn, that sometimes, hey, you're not going to be solving for circumference. Maybe you're given circumference and you have to solve for diameter or radius. Or you're given area and you have to solve for diameter or radius. That would be those reverse formulas. They are not on your formula sheet. You would just have to know how to rewrite these in the form of what you're looking for. I'm going to give it to you so that way you can study that. That's something you can memorize on a flashcard. That in reverse, instead of solving for circumference, if I needed to solve for the diameter, diameter is going to be equal to circumference divided by pi. Which makes sense, because if diameter times pi is circumference, if I divide both sides by pi, I now have diameter by itself. And I can solve for what it is if I know the circumference. Circumference divided by pi will give me the diameter. That's the reverse. Yes, dear? Yeah. Yep. Okay. For the area, again, to work in reverse, the radius, meaning I want to get r isolated. It's the same idea. Right now, I'm multiplying by pi, so instead, I'm going to take area and divide it by pi. So area divided by pi. But then we've got the fact that it's not just r, it's r squared. So the inverse operation to a square, an exponent, is to take a thing called a square root. And we'll see that. We'll practice it today. Don't worry. So this is called a square root. Inverse operation of an exponent is a root. So the inverse operation of squared is square root. Inverse operation of cubed is cubed root. Inverse operation of a power 4 is a fourth root. So they have all these roots, and we'll talk more about that in a second. Okay? Again, these two formulas are not on your formula sheet, but these two are. And all you would have to do is understand the reverse. Okay? Now, just a couple quick little practice problems. Yep, quick. Draw a circle. This is 5 inches. Now, based off of what I have drawn here, the first thing that you should always make note of is what information do you know? So based off of the picture, what's the only thing that we know right now? Connor? The radius. We know that this measurement right here is the radius. So I'm going to write that down. I'm going to say, hey, R is equal to 5. So if R is equal to 5, then I could also indicate what the diameter is. Because I know the radius, then I technically know the diameter, which is what? 10. Because diameter is equal to the radius, 5, times 2. We double it, and that's the diameter. So diameter is 10 inches. Now I know that information. And now that I know both of those, I could solve for circumference or area, no matter what it's asking. If it wants circumference, I know how to solve it. If it wants area, I know how to solve it. So here, let's say that we wanted circumference. So remember, the circumference formula is diameter times pi. So what was the diameter? 10. What is pi? 3.14. So all I have to do is take 10 and multiply it by 3.14, and then there's my circumference, which is 31.4. Don't forget your unit of measure, inches. So if it asks for circumference, boom, there's my answer. If it asks for area instead, well, then I need to use my area formula. Area is equal to R squared times pi. What was R again? 5. So I have 5 squared. What is 5 squared? 25. Remember, squared means multiplying the base times the base. So it's 5 times 5, so that's 25. So basically, we're taking 25 and multiplying it by 3.14. So 25 times 3.14 is going to give me 78.5. And that is inches squared. Remember, area is squared. So again, it doesn't matter which one it's asking for. If it wants circumference, you know the information. If it wants the area, you know the information. Just plug them into a formula. That's all this unit really is plugging this stuff into formulas and working it out. I'll give about 5 seconds, 10 seconds, and then we're going to go on to page 41.
What does that mean?
What problem is this? That's Pythagorean theorem. We're not there yet. We don't get there until next semester. Pythagorean theorem. All right. Problem number 2. Oh, sorry. My bad. 41. My bad. Page 41. Problem number 2. So based off of what they're giving us, what information do we know right now? Alicia? Good. So we know that this measurement is the diameter, and the diameter is 16 feet. So I'm going to write down, hey, diameter is 16 feet. And because I know the diameter, what else would I know then? Radius. Thank you for raising your hand, Davis. So, Davis, what would the radius be? 8. So all we would have to do is take 16, divide it by 2, and what would we, and we would get 8. So 8 feet for the radius. Now again, it might ask for only circumference, it might ask for only the area. I'm going to show both. Just keep in mind that on your homework, you just need to answer what they're asking for. So if they only want circumference, you just do circumference. If they only want area, you just do area. But I'm giving you examples of both. So circumference is the diameter times pi. So take 16 and multiply it by 3.14. What is the circumference going to give us? 50.24. 50.24, and that's feet. So there's the circumference. 50.24 feet. For the area, if they asked for area, and area is the radius to the second power multiplied by pi. So the radius in this problem is 8. So we have 8 to the second power times 3.14. What is 8 to the second power? 64. So we do 64 times 3.14. What do we get when we multiply those? 200.96. Good. And again, that's going to be feet to the second power, feet squared. That's our area. Now, like I said before, sometimes they might give you questions that's working in the reverse instead. So if I give you a problem where I say, hey, the circumference is equal to 32.656, and I want to know what is the diameter. I know circumference. I want to know what diameter is. That's when I gave you that reverse formula, that the diameter is equal to your circumference divided by pi. So all you have to do is take 32.656 and divide it by 3.14, and that would equal your diameter. So if we do 32.656 and divide it by 3.14, you're going to get 10.4. Now I didn't write a unit of measure here, so I'm just going to leave it as 10.4. That would be the reverse of your equation, that instead of multiplying diameter times pi to get circumference, you're taking circumference and dividing it by pi to get the diameter. You're working backwards. Yes, Diego. Yeah, I'm going to show you in just right now. If I said area was 84.9056, and I want to know what is the radius. 84.9056, and I want to know the radius. Again, the radius formula, when given area, you're taking the square root of your area divided by pi. That means you have to divide the area and pi first before you can do the root. You have to divide area and pi first before you can do the root. So we have to take 84.9056 and we have to divide it by 3.14 before we take the square root. So who can tell me what is 84.9056 divided by 3.14? What is that going to give us? Alex? 27.04. So when you divide those, you get 27.04. Now, on your calculator, to do a root, your root button, if you look at x to the second power, everybody looking at their x to the second power?
Yeah.
Right above it in green is a square root button. Since it's in green, what do you have to hit first? Second. You have to hit the second button, and you'll know that the second button is in use because once you hit it, the word or the thing second, that phrase second pops up on there. So that means it's in use. Then you would hit the x to the second power, and you'll see a square root button pops up. You would just hit 27.04 and then enter, and you get your square root, 5.2. That means 5.2 times 5.2 gives you 27.04. Okay? So there's the radius, 5.2. Not right now, I've still got 2 minutes. So, all right, the last kind of problem, and I'm going to do this one because we only have 2 more minutes. If I give you a semicircle, it's half of a circle, and I let you know that this measurement right here, you'll know whether it's a radius or a diameter. If it's diameter, it'll be written right in the center. If it's a radius, it'll be written off to the side, either all the way to the left or all the way to the right. So this is a radius value of 3 yards, and I want to know what is the area. What is the area? So again, the area formula, since it's a semicircle, what do you think you would have to do? If our area formula is radius to the second power times pi, that's for a circle. What do you think is the extra step I'd have to do for a semicircle? Nathaniel? Not divide it by pi, but divide it by 2. Because it's half a circle, right? A semicircle is half a circle. So divide it by 2. Okay? So that means we're going to take 3 to the second power. We're going to multiply it by 3.14. And then we're going to divide that by 2. What's 3 to the second power? 9. Be careful. Don't make that mistake. So then we do 9 times 3.14 divided by 2. And the area would be 14.13 yards squared. That would be the area. Now here's the real tricky part, the thing that some people don't seem to understand. If I said, what is the circumference? It's not the same idea. So the circumference is all around, right? It's just taking the distance around it. So for the circumference, if I divide it by 2, then that means I'm only going to have this measurement right here. So if I take my circumference formula and divide it by 2, then I'm only finding this, but not accounting for this part. So what do you think I'd have to do then? Rashawn? And then add the diameter. Perfect. Oh, great guess. So if I wanted the perimeter of this actual shape, then like Rashawn said, hey, you would take that circumference, which is diameter, and multiply it by pi. You would then divide that value by 2, but then you would have to add the diameter to it. So the diameter is what? 6. So I would take 6 and multiply it by 3.14 and then divide that answer by 2. So 6 times 3.14 divided by 2 is going to give me 9.42. But then on top of that, I have to add the diameter, which was 6. So I'm going to add 6 to it, and that's going to give me a perimeter of 15.42 yards. Yeah. Half is the radius, so double it, and that's the diameter. Yes. Half is the radius. That means if I double this, that's the diameter. So 3 plus 3 is 6. That's the diameter. Your assignment tonight is this worksheet packet. It's going to look lengthy, but most of it should be very quick because it's literally plugging it into a formula and hitting enter in your calculator. Okay?